welcome back to my channel. My name is Prachi and in today's session we'll be working on the second part of organic chemistry. For all those students who are new on this channel is about studying chemistry end to end for ICSE 10th graders. So if that is something you're interested in or you know somebody who might get help from this, so please do share, subscribe and like. Now, without wasting any time, let's get started with the session. So we are starting with alkanes. So as in the previous session, we have already studied what are hydrocarbons. Then we studied what are saturated, unsaturated hydrocarbons. And then we went ahead understanding what are alkanes. So alkanes are those hydrocarbons in which all the bonds that you see are all single bonds. That means carbon-carbon covalent bonds are single covalent bonds. Since it's a single covalent bonds, the entire compound is generally very stable under normal conditions and will not easily react. So that is one of the reasons alkanes are also known as paraffins. Then as we study ahead, alkanes also show isomerism, that is when you have the same formula but different structure. So we studied two types of isomers in the previous session, that was chain isomerism and position isomerism. We'll again do the examples in the session, but if you want to understand that in detail, I will drop the link in the description box and you can check that out. Now, once we move ahead with alkanes, the first member of the alkane series is methane. Methane is a major constituent of a greenhouse gas. That is because it has great affinity of letting warmth, or you can say heat, and it gives out a lot of heat. So once we move ahead, you will get more clarity on that. So let's go ahead. Alright students, let's get started with alkanes further. So alkanes, as we discussed, all linkages between the carbon atoms are single covalent bonds. It's a saturated hydrocarbon. Why do we say saturated? Because all the valencies are satisfied, therefore it is saturated. The formula that represents alkanes is CnH2n plus 2. Many alkanes are flammable. That means they are good fuels. When you burn it in the presence of oxygen, you get carbon dioxide, water and a good amount of heat. Methane is the principal component of natural gas and butane is a lighter fluid. Now they are called paraffins. As we discussed, paraffins means low reactivity under normal conditions. Now we have methane, ethane, propane. So it is suggested as per the ICSE syllabus that you should know all the carbon compounds till 5 carbon chain at least. So I have written till pentane and I'll be showing you how the formula looks like. So this is single carbon, then you have 4 H's along with that. This is methane. Ethane is 2 carbons and then all the valencies satisfied by hydrogens. So as we go in this session, I may not be satisfying all the hydrogen valencies. I may just write carbon-carbon. So it is understood that all the left out valencies are satisfied by hydrogen. You cannot leave that out for your examinations. So make sure in your notes also you complete the hydrogen valencies. Moving on to propane. Similarly, you have 3 carbon-carbon chain. Then butane is 4. Pentane is 5. 1, 2, 3, 4, 5. Now, alkanes also show isomerism and they generally show chain isomerism because position isomerism is generally moving your groups. For example, you have double bonds. So moving double bonds at a different position will give you position isomerism. But in alkanes, all bonds are single bonds. So alkanes only show chain isomerism. That means break the chain from the corner, bring carbon at a different position. So that is chain isomerism, making difference in the chain structure. So let's look at the first one for butane. So first is 1, 2, 3, 4, regular butane, also known as N-butane, means normal butane. The next one is get rid of the corner carbon, bring it in the middle of the chain. So that would be 1, 2, 3, and then you put the carbon right here. So this is also known as isobutane. That is the name given to methyl propane. What does iso means? Iso means that at least one carbon has 3 other carbons attached to it. So isobutane. Similarly, pentane also shows isomerism, and in this case it will give you 5 isomers. So the first one would be normal pentane, 1, 2, 3, 4 and 5. And the second one would be get rid of one carbon from the corner, bring it somewhere in the chain. 1, 2, 3, 4, anywhere in the chain. And the third isomer would be to again break one C from the corner and bring it in the middle. So 1, 2, 3, 4 and 5. So this is neopentane. Now moving ahead, we have methane. Methane is a greenhouse gas. That means it has a good affinity to absorb heat radiation when they are trying to escape the Earth's atmosphere, hence giving rise to the Earth's atmosphere temperature, also therefore known as a greenhouse gas. So methane is a primary constant of natural gas. It absorbs outgoing heat radiation from the Earth and thus contributes to the greenhouse effect, and so is considered a greenhouse gas. If you are asked to write a short note on methane as a greenhouse gas, you should be able to explain the initial part of it. You should be able to give in a couple of sources and also able to tell that there are certain efforts being put in to make sure that we are minimizing the use of methane, or we are using it in an efficient manner so that the emissions are not that high. So your entire answer formation would be according to that. If you get this can be somewhere for 2 to 3 marks. Then moving on, we have the lab preparation of methane. So in the lab preparation, we have sodium ethanoate, also known as sodium acetate, which is reacting with soda lime. Now, for all these reactions, make sure that you are looking at the reactants, the conditions. You remember the conditions, and if there is any exception given, or what is the collection of the gas. These are important things to remember. So let's start with the reactants. You have sodium ethanoate or sodium acetate reacting with soda lime. Why are we using soda lime and not sodium hydroxide? Because sodium hydroxide is deliquescent, which means it is in liquid, or it has a tendency to become liquid. And for this particular reaction, we need granules or something that is a bit solid in nature. Therefore, we use soda lime, which is a combination of sodium hydroxide and calcium oxide. We heat up this combination, that is sodium ethanoate and soda lime, up to 300 degrees Celsius. We have a tilted tube through which methane passes, and then methane is collected by downward displacement of water, because it is slightly soluble in water and it is lighter than air. So let's look at entire thing. First thing, reactant sodium ethanoate and soda lime. Second thing, why not sodium hydroxide? Because sodium hydroxide is deliquescent. Then what is soda lime? It is a mixture of sodium hydroxide and calcium oxide. Then let's look at the procedure. So sodium acetate and soda lime are in the test tube right here, and then you have the gas flowing from here to the delivery tube and then collected here by downward displacement of water. Okay, so let's look at the reaction now. So you have CH3COONA. So don't learn it like just for ratification. Understand what the structure would look like. So CH3. So CH3 connected with another C that has a double bond O and a single bond ONA. And this is reacting with NaOH. So now, what is coming out? Na2CO3. That means this and this is being combined. CO3. So CO2 is here and another O is coming out from here. So that technically, this entire portion is coming out, and instead of this hydrogen will go ahead and combine with CH3. So when that left out H goes ahead and combines with CH3, it gives you a CH4, and rest everything becomes a byproduct, Na2CO3. CO3 comes along with that. This reaction happens at a 300 degrees Celsius temperature. So any reaction that you understand in this manner, you don't have to rectify it. You can simply imagine what the structure may look like and what the output would be. Now moving ahead to the collection of gas, the gas is evolved and is collected by downward displacement of water, since it is slightly soluble in water and lighter than air. Then we have the lab preparation of ethane. This is being prepared from sodium propanoate. Why is that? Because ethane is C2H6. So you would need propanoate to combine one hydrogen in it and get rid of one carbon from that. So that will give you ethane. So sodium propanoate and soda lime. So the procedure is similar to the previous diagram. Let's look at the reaction for this one now. So you have the similar thing, C2H5. It is combined with single bond C, double bond O, single bond ONA. And this is combining with NaOH. So what is coming out? So this entire thing will combine with NaO. This hydrogen will go ahead and combine here. So what will that bring you? That will give you C2H6 as ethane coming out, and then everything else becomes a byproduct. Similar conditions in the presence of calcium oxide and 300 degrees Celsius. Collection, again downward displacement of water. Now let's move on to the other methods of preparation. So you have iodomethane or methyl iodide and bromoethane or ethyl bromide. They are reduced by nascent hydrogen at ordinary room temperature. So when we are saying reduced, that means nascent hydrogen gets combined and gets rid of that halogen. So iodomethane, what does that mean? Methane has iodine with it. And nascent hydrogen will get rid of that iodine and try to get itself fixed in CH3. So CH3I. So what will the structure look like? So this is carbon, 3 hydrogens and 1 iodine, and you have 2 nascent hydrogens. So one of the hydrogen will combine with iodine, come out as Hi, and the other hydrogen will get combined will replace iodine and give you CH4. Similarly, C2H5Br. So C2H here, and one is your Br. So one of the H will combine with Br and give you HBr. The other H will combine in the formula and give you C2H6. Now, nascent hydrogen, how is that produced? It is produced by the action of zinc powder on dilute HCl or zinc copper couple in alcohol. So you need to remember this portion. If you do not understand this, please let me know in the comment section. I will make a short video helping you understand what this method is. Alright students, let's move on to the chemical properties. So the first property is combustion. So alkanes generally show 2 types of combustion. One is complete and one is incomplete. Incomplete is when we have insufficient supply of oxygen, and complete is when you have a good amount of oxygen available. So when complete combustion happens, you get a bluish sooty flame which gives a large amount of heat, and it is also a good gaseous fuel. So if you would have seen the gases that like a kitchen gas that you see, so it burns with a very good blue flame, and sometimes when you put in a very big vessel and not enough oxygen goes there, that particular flame turns into yellow. So this is when you have good amount of good fuel. Burning completely gives you a bright blue fuel, bright blue flame. Now let's move ahead. You get a large amount of heat. It is a good gaseous fuel. So CH4 plus oxygen gives carbon dioxide, water plus heat. Then same thing with ethane. C2H6 plus oxygen gives you carbon dioxide and water plus heat. Then when you have combustion and insufficient supply of air, you get carbon monoxide, and when even less oxygen is available, then you just get carbon which is with still less oxygen. So soot is used in the preparation of printing, inks and tires. So what happens is when you get insufficient supply of air, then the flame also produces black soot. So for example, if you have seen that a big vessel is kept on the gas for a longer period of time and not sufficient oxygen is reaching, then the base of the vessel turns blackish, and if you touch it, it would come out on your hand. So that is soot, and that soot is used in the preparation of printing inks and dyes, and that happens because of insufficient supply of oxygen in the combustion of the gas. Now, the second property that alkanes show is substitution reaction. Substitution reaction is simple. That means you have ethane or methane, 4 hydrogens are there. Under certain conditions, another compound will come in, another element will come in, replace one hydrogen and takes its place. So, let's look at this substitution reaction. So, reaction with halogens. Alkanes react with chlorine, bromine or iodine in the presence of sunlight or UV light to give halogen substituted product that are known as alkyl halides. So let's look at it. So the first thing is methane reacts with chlorine in diffused sunlight or when heated to 600 Kelvin to give chloromethane. So what does that mean? You have methane, so 4 H's are there, and you have chlorine gas. So what happens is, as it reacts, one hydrogen combines with one chlorine and gives you HCl, and one chlorine will replace hydrogen. So that will give you C combined with chlorine, and all the other 3 hydrogens will stay as is. Now this reaction does not stop here. It's a slow process. It will continue happening. Moving ahead, it would again replace another hydrogen. The chlorine will replace another hydrogen, and you will get CH2Cl plus CH2Cl2 plus HCl, and then again you will get CHCl3 and then CCl4. That means slowly it will replace all the 4 hydrogens and chlorine will take place of all the 4 hydrogens. So this is what you will get at the end. The substitution products can be separated by fractional distillation because of appreciable difference in their respective boiling points. That means at different boiling points, different products are liberated. So slowly you can separate out these products from each other. Same thing would happen when you have ethane. You have C2H6. So slowly chlorine keeps getting added up, and all 6 hydrogens will come out. Okay. So let's look at that. So you have C2H6. So C2, all valencies are combined or satisfied by hydrogens. You are getting chlorine. So one hydrogen combines with one chlorine, gives you HCl. Other chlorine replaces hydrogen and you get C2H5Cl. Moving on, the same thing will continue happening till you lose out all hydrogen and end up with C2Cl6. All alkanes react with chlorine, bromine and iodine in a similar manner, producing the corresponding substituted products. In the exam, it's not necessary that they will ask you substitution with chlorine only. They can give you bromine or iodine. The method stays the same. Now, let's move on to the second hydrocarbon, that is alkenes. Now, alkenes are when you have carbon-carbon double bonds. These are known as unsaturated hydrocarbons because not all valencies of carbon are satisfied by hydrogen. Okay, you have one carbon attached to another carbon also by double covalent bond. The formula that you have is C2H2N. Lower members produce oil products when treated with chlorine or bromine. That is why they are also known as olefins. Okay, olefins. So because lower members produce oil. Now let's look at some examples. So you have ethene, also known as ethylene, propene, also known as propylene, butane, also known as butylene, and similarly pentene, also known as pentylene. Now the formulas, you can understand the structure from here. You have, for example, let's say take butene. So 1, 2, 3, 4. Now you can put up your double bond over here, and then you can satisfy all the valencies. So this is butene. Then you have pentene, 1, 2, 3, 4, 5. Put your double bond right here and satisfy all the other valencies. Now let's look at the kind of isomers alkenes show. So since you have a double bond here and the double bond can be placed anywhere in the chain, So that is why alkenes also show position isomerism along with chain isomerism. So position isomerism is when the position of the double bond can go anywhere in the chain. For example, one butene. So this is where your double bond is kept right here. Then the double bond came in the middle. So two butene. So these two are your position isomers. When we talk about chain isomers, that means you're breaking and moving the chain. So you have the four carbons like this, then you move ahead, move the corner carbon and bring it right in the middle. So you get something like this, 2-methyl propene. So this is your chain isomerism. I hope this makes sense to you. Now let's move ahead with ethene. So ethene is the first member of alkene present in natural gas, occurs as a plant hormone. Occurs as a plant hormone, therefore it is used for ripening of fruits. So if you would have heard, for example, mangoes. So mangoes are stored and then there is some salt that is kept in a potli inside that. And after a few days when you take that out, all the mangoes are ripe and ready to be eaten. So that is where we use ethene. Okay students, let's move ahead to the lab preparation of ethene that we get by dehydration of ethyl alcohol. The reactants we are using is ethanol and concentrated sulfuric acid. The temperature we are maintaining is 170 degrees Celsius and the ratio of your reactants is 1:2. One part of ethanol reacting with 2 parts of sulfuric acid. And now the note that you have to remember in this is that ethene gas is passed through NaOH when we are collecting it, because you have carbon dioxide and sulfur dioxide, which are certain impurities which are formed by the oxidation of the acid. So let's look at it again. You have ethanol reacting with concentrated sulfuric acid in the ratio 1:2 at a temperature 170 degrees Celsius. Ethene gas is passed through NaOH. Why? To remove carbon dioxide and sulfur dioxide. Collection is by downward displacement of water again, and we add some aluminium sulfate in order to avoid frothing of the water while collecting it. Now let's move on and look at the apparatus. So you have concentrated sulfuric acid. You have the gas being prepared. Ethene is coming out from here, passing through NaOH to get rid of the impurities. Then you move ahead and you have water with aluminium sulfate to avoid frothing. Otherwise, the frothing will start occurring in the collecting jar. So let's move ahead and look at the reaction now. So we have CH3CH2OH. So let's understand what is happening in the reaction. So don't learn the reactions by heart for rectification again. Just try and understand what is happening in the reaction. So you have CH3CH2OH. So C, 3 H's, C, 2 H's and OH. So OH. Something like this. It is reacting with H2SO4. And what is happening? Water is coming out. So H and one of the H's would go from here. One of the H's will go from here. Okay. So let's look at that. So your H2O is coming out. What are we left with? You are well left with HSO4, which will combine in this place. So C, I'll just write it here. HSO4, another H here, another H here, and the same thing. This is the first step. Your water came out. Now, in the next part of the reaction, you have HSO4. So 1, 2, HSO4, and you have in excess of H2SO4. So H2SO4 will come out. So what would happen is this part will combine and get out. So what is happening? This part is being combined and getting separated from the structure. So you have H2SO4 coming out. When you have H2SO4 coming out, you are left with 2 carbons and you are left with only 4. 1, 2, 3, 4. Only 4 hydrogens are left out. So 1, 2, 3, 4. Now since only 4 hydrogens are left out, what will the 2 carbons do? They will develop a covalent bond between themselves to satisfy the valencies. So this is what is happening in your reaction. You can also write the reaction in one single step, that is C2H5OH in the presence of concentrated H2SO4 at 170 degrees Celsius will give us ethene, that is C2H4 plus water. Now, ethene is also prepared by passing ethanol vapors through a tube containing alumina at 350 degrees Celsius. This is another type of preparation. So you have C2H5OH in the presence of alumina at 350 degrees Celsius, giving us ethene and water. Now let's understand what is dehydrohalogenation. So dehydrohalogenation of ethyl halide. Now, or haloethanes by alcoholic hot concentrated potassium hydroxide. This condition is very important. Alcoholic hot concentrated potassium hydroxide. So KOH, alcoholic hot and concentrated, remember that. And alkyl halides or ethyl halides they are talking about. So C2H5Cl combining with KOH will give you ethene, KCl plus water. So if you try and understand, this K will combine with this Cl, so you get KCl out, so you get rid of this. Then you are left with OH, so one H will get out from here, give you water, and whatever is left out will give you ethene. Similarly, if we move ahead to this, K will combine with bromine and give you KBr. OH will combine with one of the hydrogens and give you H2O. What is left? C2H4 is left. Alright, same thing with iodine also. If you still face any doubts and you want to understand any type of reactions in detail, please do mention that in the comment section and I will help you out. Let's move on to the chemical properties. So the first is addition of hydrogen. So addition of hydrogen is what happens is the double bond will break, create the space there for two hydrogens, and the hydrogens will come and attach themselves. So one double bond, so you have two H's here, two H's here. Once this covalent bond breaks, you have available valencies on this, and hydrogen will come and satisfy those valencies. That's it. So let's look at the reactions. So addition C2H4 plus H2 in the presence of nickel at 200 degrees Celsius, giving you a C2H6, that is ethane. Now the catalyst can be platinum or palladium at ordinary temperature, or it can be nickel at 200 degrees Celsius. Okay, so platinum or palladium at ordinary temperature or nickel at 200 degrees Celsius. Now addition of halogens. So halogens are also added in the similar fashion. You have ethene, one of the bond will break, create two available valencies or available bonds. Chlorine will come in and get attached at both the places together. So CH2 combining with chlorine, the bond will break and chlorine will come in attached. Same thing will happen with bromine. Now, reaction with fluorine is explosive, hence the compound formed is not stable. That is the reason we are not studying with fluorine. You need to know why it is not possible with fluorine, because the reaction is explosive and hence the compound formed is not stable. Then when you look at iodine, the similar thing is happening, but you have to remember that reaction with iodine is very slow and diiodoethane that is formed is very unstable. Okay, so it eliminates the iodine readily and regenerates the ability of ethene. Okay, so first of all, the reaction is slow, and once you get diiodoethane, it is unstable. It will give out iodine very quickly and come back to ethene. So you have to remember this for reasoning questions. Now, bromine solution in CCl4 has a reddish brown color when added dropwise to ethene. The reddish brown color of bromine disappears due to the formation of colorless dibromoethane. Alright, I hope this makes sense to you. Now moving ahead to combustion of ethene. So again, if ethene is burned in the presence of oxygen, it will give you carbon dioxide, water plus heat. You will get a sooty flame plus heat. When you have excess air, then it will burn as bluish flame that we discussed in alkanes. Now, moving ahead to the last part of the chapter, that is alkynes. So, alkynes are unsaturated hydrocarbons. In these, the formula that represents alkynes is CnH2n minus 2. You have carbon-carbon triple bonds, triple covalent bond available. So let's look at certain examples. You have ethane, also known as acetylene. You have propyne, also known as alylene. You have butane, which is known as crotonylene, and you have pentane, which is also known as propyl acetylene. So you need to remember all the common names and the IUPAC names. Now let's look at the structure. So you have a triple bond, then you have a triple bond right here, triple bond and a triple bond. Now alkynes also show isomers, both chain isomers and position isomers. So let's look at the examples. You have butane. So you have 4 carbons. This is position isomers. So the triple bond was here and then it jumped from here to the center place. That is over here. So this is position isomers. Then you also get chain isomers. Now, for example, you are drawing all the isomers for pentane. So you will make all of them. For example, you will first give the position and then you will also change the chain. So first you have changed the position from here to here, and then you have taken out 1 carbon from the corner and brought it in the center. So you are getting 3 different type of structures. Now ethane, C2H2, also known as acetylene, unsaturated and not found in free state. This is the first member of alkyne series. Now laboratory preparation of ethane. The reactants that we have is water and calcium carbide, and the reaction is explosive. You have to remember that the reaction is explosive. When we look at the structure of the procedure, you have the thistle funnel in which you have water. You have a pinch cork to control the amount of water you are adding in, calcium carbide, and you have ethane being collected by downward displacement. Now let's move ahead and understand the reaction. Now in the reaction you have calcium carbide, that is CaC2 plus water. So CaC2 plus water, what is happening? C2H2 is coming out. So C2H2, and whatever is left, that is Ca and extra H's. So that will give you CaOH whole twice. So C will combine with the hydrogens of water, give you C2H2. You will still have extra hydrogens and oxygen. So that will give you CaOH whole twice. Collection is by downward displacement of water because it is insoluble in water. Now purification. Now this you have to remember. I have written it in a fashion that should be understandable. What are the impurities present? You have in total 4 impurities: phosphine, hydrogen sulfide, ammonia and arsine. Hydrogen sulfide, ammonia and arsine, these 3 passing through water, these impurities are absorbed. Okay. And how is phosphine being removed? Acidified copper sulfate or acidified potassium dichromate. Okay. So 4 impurities: phosphine, hydrogen sulfide, ammonia and arsine. The later 3 can be removed by water because they are absorbed in water. But phosphine, just remember any one of them. It can be removed by acidified copper sulfate. Okay, remember one of them. Let's move on. These impurities are present due to calcium sulfide and calcium phosphide in calcium carbide. This is not so important, as important the impurities and how they are being removed, but you should still know. Now note, flask should not contain air. Why? Because ethane forms an explosive mixture with air. Okay, so that is the reason we keep the flask filled with some inert gas. So let's look at that. Flask should not contain air as ethane forms explosive mixture with air. The air of the flask is displaced or replaced by oil or some inert gas. Now another type of preparation that we have is from 1,2-dibromoethane or ethyl dibromide. So let's look at that. So CH2Br, you have KOH being added. Now what would happen? KBr will come out. So K and Br, this will come out, and 2 of those molecules, so KBr will come out twice. So 2 KBr. What are we left with? We are left with CH, and 1 of your water will come out, combining with this. Okay. So when water combines, H2O is formed by taking hydrogens from your CH2Br. So you end up getting water, H2O, KBr, 2 molecules of that, and whatever is left. What is left? You have CH, single bond CH. Okay. How will you satisfy that? Of course, carbon will combine carbon-carbon will end up making triple bond instead of a single bond. Chemical properties: oxidation of ethane, do not oxidize completely and gives a sooty flame. In excess air, gives a brilliant white flame. Excess air means when you're directly providing oxygen to it. So if you look at this again, if you have good amount of oxygen in that, you will get carbon dioxide, water and heat. Now addition reaction, you have a triple bond, add something to it, you'll get a double bond. Again add something to it, you get a single bond. Triple bond, double bond, single bond. Because every time when you're trying to add something in it, one of the bond would break, create space for an element and bring you double bond. And again you try add something, another bond will break, create space and another addition would happen. So addition of hydrogen, catalytic hydrogenation. The catalyst is nickel, platinum or palladium. First stage, C2H2 plus hydrogen giving you ethene. Okay, so what happens in this case is C triple bond C and you're adding hydrogen to it. So you already have how many hydrogen? One each. So one of the bond will break and it will create space one hydrogen. So H. Again this would happen. So you have double bond C and all the valencies are satisfied by H's. You try and add H here. So one of the bond will break and create space for hydrogen. So the second stage is this. Now addition of halogen, same thing will happen. Ethane is an inert solvent, CCl4. So again you have chlorine from CCl4 combining here and you have triple bond going to double bond giving you a single bond. Okay, now it reacts vigorously with chlorine gas in the presence of sunlight to give out flames. Okay, so you have to remember that. I'll just mark this important. Now reaction with bromine and carbon tetrabromide when reacts with ethane gives a brown color which disappears. So you have C2H2 and you're adding bromine to it, so you get C2H2Br. Then again you're trying to add bromine to it, so you get C2H2Br4. Now reaction with iodine, same thing is happening. Now iodine reacts slowly with ethane in the presence of alcohol to form diiodo derivative. Okay, so what diiodo derivative is formed. Now I hope whatever we have discussed so far, now that these reactions are pretty simple, you're just adding bromine, you're just adding iodine. Even still, if you face any doubts in any of the reactions, I do not mind creating a small video just for understanding of all the reactions only. So if that is something that might help you out in understanding the chapter better, so please do let me know either on the Telegram channel or you can drop a message in the comment section and I will get back to you on that. So my dear students, this is where we conclude today's session. In this session, we have thoroughly discussed how the reactions are being formed and how your products are coming out. So instead of mugging up those reactions, try and focus on what the compound is looking like, what is the structure, what are you trying to add, and what are you trying to achieve out of it. So if you try and follow that method, then in the exam also, you can use logical reasoning to understand and write your reactions correctly. Now, I hope this was very helpful for you. Still, if there is any portion that you may need more help on, just feel free to reach out to me. Thank you so much and we'll catch up in the next session. Make sure that you like this video, subscribe to the channel and also share the video with your friends. Thank you and let's see you again.